Hello folks, I was asked how I build these Jensen windmills, and while I generally don't give the information out, but for home or personal use, I'd be more than happy to share what I learned. And we'll start off at the top. This fin here, the fan blade, has 12 blades on it. And how I knew to position or paint in the red, I tried masking tape and that was just a nightmare. But what I did was take a vernier here and set it at 0.200, and then following the trailing edge, I just scribed a light line into each blade and just merely painted that in. And that worked really well and pretty consistently. And if you go over, you can scrape it off with a razor blade easy enough. Let's go around to the hub. This hub is probably the most critical part of this whole unit. And let's see, this one is just right over ½ an inch. It's 0.529, and it can vary a little bit. But the distance between where the groove is and the end is roughly 285. And I left just a little bit in front of that groove, and that's about 0.100. The groove is roughly 0.166 wide. And then I put 2 set screws on either side. Of course, this one don't have any in it, it's a sample. But that hub is slightly tapered on the back of the fan blade that holds the bearing in it. And so it's good to have 2 set screws so that you can kind of adjust it so it doesn't have a wobbly or egg running effect. The decal on the fan blade probably took me the most time to do. And that's just something that you're going to have to figure out. I made up a template, and I've got sheets of these now. And they are printed on clear water slide decal sheet. And it says an American tradition, and the Jensen and the steam engine had to be put in because I think it said since 1932 there, so I had to take that out and then also add it's still spinning since 1932. The turret right here has been threaded. That's very hard to do because there's really no jig that can hold this thing. It's amazingly tough metal, and I haven't bent or broke anything yet trying to thread it. But I hold it in my hand and have the die and the lathe and just kind of slowly thread it in there straight as I can. And after a while, it'll thread straightly. But like I said, it's 1/4 inch by 28 TPI. And what I'll do is I'll take my, I've got a little belt sander, and I'll put the shaft on there and kind of run it around a time or two to get the red paint off of it and to thin it down just a little bit because it's a little oversized 1/4 inch. Really hard to thread. And then the ladder is painted red, and the ladder and the fin blades are all fire red. That's the color they used. The belt here is 27 inches long exactly, and you want it to be a little loose because this is just, remember, just a bronze bushing there, so you don't want to put too much pressure on it. Moving down to the water tower, let's see. It is exactly 2½ inches tall, with the hole being 1 3/4 exactly from the base to the middle of the hole, and centered, of course. And this is a 3/8 inch hole, and I use roller ball bearings, and I press them in with my vise. This is oak, so it holds pretty well. And this is a 3/8 outside diameter bearing and 3/16 inside diameter. And it's a flanged, completely sealed bearing, so it works real well. And of course, I just gave it some 45 angles on the top. That's a 3/16 hole to accept a PM Research elbow, and you can use a 1/4 inch or 3/16 inch. Both look well, and I've used both, so that's not a problem. The pulleys on the bottom, all of these were made out of 7/8 aluminum round stock, and I just start with that. And this one's 0.210, but it can vary. This is the single that feeds the blade up there. The important thing is to leave a little lip right here, and I don't know if the camera's catching it, but there is a little bit of a lip, and that rides against the inside race of this bearing. So it can be really tight and not have any slop at all and not rub, since it's riding on the inside. The dual pulley here, you can make a single or a double like I did. With the double, you can run other things. This one is, and it doesn't matter much here, 0.400 basically, wide. Again, you've got a lip right here to ride on that inner inside that bearing there, and we've got a set screw right there built into the smaller one. Let's see, the outside is about $8.75 and the inside is about $6.50. So a couple hundred apart for the gearing. The base is exactly 5-inch square at the bottom, being the widest part, and it has a 10-degree taper. That's the taper of the tower, basically 9 or 10 degrees, somewhere in there. Doesn't matter a whole lot. And then I just drilled through the holes that were already in the tower into the base, and you can use them. This is oak, so these are actually machine screws, but they work well. And I believe that's it. I think I've covered it all. So happy building, and I hope everything works for you. And enjoy the build. It's a lot of fun, and they look good when you get it done. All right, thanks now. Bye.